Hi, this is going to be your pre-lab lecture for Lab A, Fermentation of Stilbene. This is an in-person lab for groups A and B and online for group C. Group A will be doing this lab the week of September 26th through October 30th. If you are watching this video and you're in group A, you probably already did the Lab A in person. And then group B will be doing this lab the week of November 2nd through the 6th. The most important thing about these videos right here is video 1. This is a video that was conducted by Dr. Rastogi in lab, and it explains exactly what we're going to do. So make sure you definitely watch this video right here. Like always, make sure you read your lab manual. Bring your pre-lab notebook to lab if you are in group B and group A. Turn in your pre-lab quiz on time. And your post-lab notebook is due Sunday at 11:59 p.m. before 11:59 p.m. For those of you in Group C, you guys will be using this data. I will explain a little bit more about changes when we go into the PowerPoint for Group C because it will vary between Group A and B. Okay. Let's get started. So we're going to be doing bromination of Stilbene for Lab 8. And it basically involves a reaction called halogenation by an electrophilic addition, where basically the pi electrons of the alkene attack the electrophile and generate a carbocation that we can see right here. And then the carbocation in turn is attacked by the nucleophile, and we get a disubstituted alkane. Okay, so chlorination and bromination, they're the two most common halogenations, and the addition of halogens to alkenes yields 1,2 dihalides. We're going to be using pyridinium tribromide just because liquid bromide can be very dangerous in the lab setting for educational purposes. That's why we are going to be using this instead. Like I said, it's an alternative to liquid bromide. Liquid bromide can be hazardous and presents a hazard in the teaching laboratory. It has a lot of dangerous fumes. So do not add liquid bromide to your reagents or what we're using in your safety part of your notebook. Make sure you put pyridinium tribromide. So for this lab, you will be given an unknown stilbene to perform the bromination reaction on, and it is your job to determine whether it is a trans or a cis. We will know if it's trans or cis depending on its melting point. Trans is more thermodynamically stable, which means it's going to take more heat to break it apart. That's why its melting point is higher than the cis melting point. Afterwards, we're going to be using a silver nitrate test, and it will indicate the presence or absence of a precipitate. That way we know if bromine is actually in our product. Okay, this is already what I showed you, the electrophilic addition mechanism. Now right here we can see the bromination and our stilbene, and like I said, you guys will determine if it's cis or trans. Right here we have the pyridinium tribromide with our glacial acetic acid, which is our solvent. And right here we have our trans and our cis. Like I said before, trans is more thermodynamically stable, so its melting point is going to be 238 degrees Celsius in comparison to the cis stilbene, which is 110 degrees Celsius. Okay, I want to go over a little bit of this lab just so you guys are not lost. You guys are very prepared. So first thing we're going to do is gather 20 milliliters of acetic acid, 1 gram of stilbene, and 2 grams of pyridinium tribromide, and place 2 boiling stones in a round bottom flask. Remember, it's important that you guys do not put grease before. You guys have to put it after everything is inside your round bottom flask. Afterwards, we're going to set up for a reflux. And remember, cold water in, hot water out, your heating mantle. This should be like an orangey color, so we're going to wait for it to dissolve, and everything should be dissolved after you take it off. I suggest for the first 12 minutes to heat it at 6, and then for reflux to turn it up to about 8 for about 12-ish, 15-ish minutes until everything is dissolved. Afterwards, we're going to wait for it to cool. Do not take it off immediately and just pour it into your water. Right here it says add H2O. So instead, I would recommend when you're doing your ice bath, make sure you put your beaker, add your water while you're refluxing. And once you're refluxing and you let it cool to room temperature, go ahead and add your mixture to the water that's already in the ice bath. Afterwards, we're going to let that sit for about 15-ish minutes, and we will then vacuum filtrate it, and then we're going to oven dry, not air dry. So if you want to add that to your changes, go ahead and do that. Then we're going to weigh it in a watch glass and determine the crude product yield. Now, the silver nitrate test is a halide ions test, and it determines which halide we have in our product. If you have chlorine, bromide, or iodine, you would have a white solution or a cream solution or a pale yellow solution. In lab, we should expect a cream solution, theoretically. For your calculations, you're going to determine experimental and percent yield of crude product. In pre-lab calculations, make sure that you put your reactions that you're using. It is important that you know these reactions because you will be tested on them on your finals, so you might as well already start learning them. For changes, I put to be announced. Like I said, you can add, if you're in group C, you can add oven dry instead of just air dry. But that will be it for group C. For group A and B, I will be explaining the changes in lab. And that's all I have for you guys. I'm going to be sending out a poll to see if you guys want a, it's not going to be an in-depth review for the final, but it will be a list of topics. If that's something you guys are interested in, let me know and I will send that your way. And that's all I have.